Okay, these are the solutions to 2024 AS1 examination. So this is CCEA examination board. Okay, first thing you do is read the question, and it says, does it tell you what to give the significant figures to? I don't see it there. So we'll just get cracking, and that's us cracking. So that's us started here. The total is 100 marks. So in your first question, it says, vectors question says find P, where P is equal to Q minus 2R. Nicest way to do this is write these in column vectors. So P is equal to then, let's just make this a little bit thicker on this pen. So P is equal to then my Q, which is 5, 2, minus 2 times my R, which is 1 minus 3. So that's just going to be 5 minus 2, and then 2 minus 6, sorry, so that's plus 6. So it's going to work out to be 3, 8 is all we're going to have. So that's first question done. Hence find the magnitude of P and the angle it makes with the x-axis. What was my P? It was 5, 8, was it? And let's just check that. It's 3, 8. So 3, 8. And we want to find the magnitude of this thing and the angle it makes with the positive x-axis. Let's just do a wee sketch here and see. It goes 3 to the right and 8 up in the air. So there's your angle theta, and your magnitude would be the length of this. So you just use Pythagoras. So your magnitude of P is equal to 3 squared plus 8 squared. Square root of that and see whatever you get. So just leave that square root of 3 squared plus 8 squared, and that was root of 73. And then the exact value, or sorry, the rounded value will go to 3 sig figs here, 8.54 to 3 sig figs. Now the angle part is just using SOHCAHTOA, so we know tan. Apologies, I don't know why this is going like this. You use tan, so it's going to be tan of theta. Okay, next wee bit we've got to do here is just find our angle theta, or theta. So theta is just going to be, using our SOHCAHTOA, tan theta is going to be equal to 8 over 3, which means theta is equal to tan of minus 1 of 8 over 3. Tan of minus 1 of 8 over 3 is equal to, and 69.4 degrees, and that's the 3 sig figs, or 1 dp, whatever way we want to set. Okay, right. Really, really easy, this question. This is unbelievable. This is on an A-level maths paper, to be honest. It says find the midpoint of AB. Your midpoint formula, first of all, if you've got 2 points, x1, y1, and another point which is x2, y2, your midpoint is just going to be equal to x1 plus x2 divided by 2, y1 plus y2, and divided by 2. So for this particular one, your midpoint is just going to be equal to minus 1 plus 3, and that gets divided by 2, and 2 plus 10 and divided by 2. So really easy. So that's going to be 2 divided by 2 is just going to be 1, and 12 divided by 2 is going to be 6. So your midpoint is 1, 6. Okay, happy days are giving marks away here. 2 marks, easy marks. The gradient of AB. So you write down, let's just write down those points again. A was the point which is minus 1, 2, and B was a point which was 3, 10. We want to find the gradient of AB. Your gradient formula is the following. So gradient is equal to the y difference over the x difference. You maybe remember rise over run as well. But in this case then, the gradient is equal to, I'll start with the one on the right here, so 10 minus 2 all over, and it's going to be 3 minus 1. I would just write it in that for all the time it takes. That's going to be 8 over 3 minus 1 is going to be 3 plus 1, so it's going to be 4. So my gradient is equal to 2. Now what it says is, hence, find the equation of the line perpendicular to AB. So it's perpendicular, so gradient first of all is the negative reciprocal of 2, so it's negative 1/2. Okay, and also which passes through, it's a perpendicular bisector which that means it passes through M. And remember our M was 1/6 from memory. Let me just check. No, 1/6 it was. Okay, so we've got to put this in to your general equation of straight line. Y equals mx plus c. We know our gradient is minus a half x plus c, and then we're going to fire in the m, so we're firing in 1/6. 6 then is equal to a half times 1. Minus a half, sorry, times 1 was just minus a half plus c. So we've got 6.5 then equals c. So your y is equal to minus a half x plus 6 and 1/2. Now multiply through by 2, you're going to get 2y equals minus x plus 13, which means x plus 2y minus 13 equals 0. I think that's what they wanted us to have it in the form where they're integers. Yep, that looks good enough to me. Okay, next question. Find the center and radius of the circle. I am going to do this using the completing a square method, which is not what I normally do, but I'm going to do it that way because most people seem to like it that way. I don't, but sure. Right, so I'm going to rewrite this as x squared plus 4x in a bracket plus y squared minus 2y equals 12. And I'm going to complete the square inside this bracket. So this thing here, I'm going to rewrite that as x plus 2 squared. If I do that, I get an extra 2 squared term, so I need to remember to take it away. This term here, this bracket here I should say, I'm going to write as y minus 1 squared by completing the square. And if I do that, I'm going to have to remember to take away a minus 1 squared term. Okay, to keep everything balanced. And then that means I've got x plus 2 squared plus y minus 1 squared is equal to 12. These things will fire across the other side now. And if I get that, that means that's just x plus 2 squared plus y minus 1 squared is equal to, what's that going to be? 12 plus 4 plus 1. 12 plus 4 is 16 plus 1 is 17. And then that means my center is going to be 2. It's not. It's going to be minus 2, 1, I should say. And my radius is root of 17. What would we define? Find the center and radius. Done. Right, find the coordinates of the points where the circle crosses the x-axis. Not really necessary, but I'm going to do a wee diagram here. What's the center? Minus 2, 1. So minus 2, 1. So it's going to look something like that. Now it may actually look more like that. It might cross, but just roughly where the thing is. That's all I'm doing. Okay, so right. What was my my equation? X squared plus y squared plus 4x minus 2y equals 12. Okay, we want to find where it crosses the x-axis, so that just means you put y equal to 0, which is just going to give you x squared plus 4x equals 12, which means x squared plus 4x minus 12 equals 0, and that factorizes really nicely to be x plus 6x minus 2 equals 0, which means x is equal to minus 6 or x is equal to 2. The coordinates then are minus 6, 0, and 2, 0. So my diagram was a wee bit off. It should have been more like this. Okay, where that would have been your minus 6 and that would have been your 2. Okay. The expression, lovely factor theorem question, expression. This thing then, x cubed minus 5x squared plus 7x minus a has a factor of this. So what would it say in your notes? It would say if ax minus b is a factor, then f of b over a will be equal to 0. So that's where this is coming from. So in our example, in our question I should say, if that's a factor, that means f of 1 over 2 will be equal to 0. I.e. that means 0 is going to be equal to a half cubed minus 5 times a half squared plus 7 times a half minus a. Let's fire that a across the other side. You're just going to have a is equal to, what's a half cubed? 1 over 8. A half squared is a quarter, so that's minus 5 quarters plus 7 over 2. And then just fire that in, so we've got 1 divided by 8 minus 5 divided by 4 plus 7 divided by 2 is equal to 19 over 8. I'm going to write that my a as 2 and 3 over 8. Okay, right. I seem quite fond of these questions these days. That seems to be coming up quite a bit. Right, it says here, find the first 4 terms in ascending powers of x in the binomial expansion of 1 plus kx to the power of 6, where k is a non-zero constant. Right, in your formula booklet, there is a formula which says 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 times x squared all over 2. Really, you could write that as 2 factorial. That's 2 with a wee exclamation mark. And then, first non-zero terms. The next one that would be then n minus 1, n minus 2 times x cubed all over, and I think they give it as 2 times 3, but that could be written as 3 factorial as well. But the way I like people to remember this is if it's in this form, 1 plus squiggle, well, this isn't very mathematical, the power of n, is 1 plus n times the squiggle plus n times n minus 1 times the squiggle squared, all divided by, and I'll put in a factorial, 2 factorial, plus n times n minus 1 times n minus 2 times the squiggle cubed, all divided by 3 factorial. Now, the reason I say it that way is because if you're squiggled, I suppose you can get it, like you can say, you see that it's being squared. So the squiggle in this case would be k plus x. So the k and the x are both in that bracket. So then the first one here, for example, they're being squared, they're just being multiplied. The next one over here, they're being squared, and this one, the k and the x are both being cubed. So that's just why I like to think about it in that form, okay? But the top line's what's given in your formula booklet, if you forget that method, but it's dead easy. Okay, right, let's get cracking on this. What do we got? 1 plus kx to the power of 6. So that's going to be 1 plus 6 times just kx, plus it's going to be 6 times 6 minus 1 is just 5, times, and that's kx squared, and that's over 2 factorial, which is 2, plus it'll be 6 times 5 times 4 times kx, and that's cubed, over 3 factorial, which is 6, and then you could nearly do this without a calculator. That's just going to be 1 plus 6kx, apologies, why does this thing keep changing the size? 1 plus 6kx, and then 6 divided by 2 is 3, times 5 is going to be 15, k squared, x squared, and then the 6 and the 6 cancels, 5 times 4 is 20, 20k cubed, x cubed. So that's what you've got. Okay, given that the coefficient of x squared and x cubed are equal, okay, so coefficient of x squared equals coefficient of x cubed. I would always write that down, and it's because it's an easy one here, but I would write it down because sometimes it says given that the coefficient of x squared is twice the coefficient of x cubed. People don't understand when they try and put the letters in, I should say, where the number goes. But if you put this in, so say it said given that the coefficient of x squared is twice coefficient of x squared is twice the coefficient of x cubed, then you would know you'd put your 2 here, and then when you go on to your next line, it makes it a lot easier for you to think about what's actually going on. Okay, right, let's go back. We need to find what's my coefficient of x squared is 15k squared, and the other one, the cubed one, is 20k cubed. So 15 k squared and 20k cubed. Find the value of k. So bring it all to one side, you'll have 20k cubed minus 15k squared. Factorize, I could pull out a 5k squared, I suppose, and that'll give me 4k minus 3. So k is equal to 0, which isn't going to work. Or here, 4k equals 3, k is equal to 3 over 4, which is going to be what we're wanting. Oh, lovely. Right, we tran proof, or trig proof, I should say. So now this thing has changed again. Now keeps changing the thickness of the pen. I do not know why. Right, we're going to work our left-hand side. Now, look at in a proof. What you want to do is you want to look where you're trying to get to. So I'm going to work with my left-hand side. My left-hand side is in terms of tan, and my right-hand side is in terms of sine and cos. So that's the first thing I want to do. I want to change my left-hand side, get it in terms of sine and cos. So it's tan is the same as sine theta over cos theta. So 1 over tan would be the reciprocal of that, so it would be cos theta over sine theta. Now again, look at where you're trying to get to. My right-hand side has got one term basically. So we need to change, we've got two terms. We want to make them be one term. So take a common denominator, and I'm going to write my common denominator as, I'll just write it as cos theta sine theta. My top line up here needs to get multiplied by sine, so it becomes sine squared. This line up here needs to get multiplied by cos, so it becomes cos squared. What do we know sine squared plus cos squared is equal to? It's equal to 1. And then the bottom line, we could write that as sine theta cos theta, so literally just reorder them. That equals my right hand side. Happy days, I know I've got the full marks. That's what I was looking for, and I've done it. Okay, solve this one. Lovely. Right, solve. So you've got to get all your trig functions to be the same thing. I'm going to change my sine squared to be 1 minus cos squared. Multiply out. Bring it all to one side, put it equal to 0. So, oops. So I'll bring it to the right hand side. So I just like to have the quadratic term be positive. Is that right what I've done? I think it is. Minus 4. So that's what we have. And does that factorize? I'm just going to rewrite that because I would work with it this way normally, but I know people don't like that. So what people would do would be change that to 2y squared plus 7y minus 4. And that will factorize then. So my sum is equal to 7. My product is equal to minus 8. My two numbers are going to be 8 and minus 1. So we'll rewrite this thing then as 2y squared plus 8y minus y minus 4. So that's going to be 2y times y plus 4, then minus 1 times y plus 4. Rewrite my common bracket. What was it? Y plus 4, 2y minus 1, which means y is equal to minus 4, or y is equal to a half. We've invented this y really, so it was cos theta is equal to minus 4, which is impossible. Brilliant. That saves us a wee bit of work. That means we're only doing one cast diagram, I should say, or cos theta is equal to a half. Shift and cos and get your basic angle. I can't believe I'm doing this, that's a disgrace. Just to check, cos to minus 1 of a half, this should be 60 degrees. It is, yeah, 60 degrees, 60 degrees. Now we're doing our cast diagram. And it's positive, so it's in here or in here. 60, 60. What was my range? I forgot my range. 0 to 360. So it's going to be 60 degrees or 360 shy of being 360. So 60 degrees or 300 degrees. Question 6 is a logs question. You've got 4 to the power of 2x minus 1 is equal to 25. So we want to take logs. Now I've started just using the natural log button, so the ln button, but you can still use log if you want, as long as you're consistent. So as long as you use either lns on both sides or logs on both sides, it'll be the same. So I've taken lns. I'll say then ln of, then it's going to be, sorry, 2x minus 1 in a bracket upon ln of 4 is equal to ln of 25. Now, this really confuses people. So if you had something different, so say it had said something like this, say it had said like 2x minus 1 times 6 is equal to 7, what you would have done is multiplied out your bracket first. Okay, so the same idea. So if you ever get a question where you're thinking it looks different and I'm not too sure what to do, just change it in your head and think what would it be if they were simpler numbers. So we're just going to multiply out. I'm going to have then 2x ln 4, then minus ln 4 is equal to ln of 25. And then I'm going to just bring the ln 4 across. So it's going to be ln of 25 plus ln of 4. And then what's happening here is your x is being multiplied by 2 and also by ln 4. So the 2 and the ln 4 have to go across to the other side. So your x is going to be equal to ln of 25 plus ln of 4. And those two things come across to the other side and they now divide. So divided by 2 ln 4. And then I have already done this one out. So hopefully I've done that correctly. 1.66 to 3 sig figs. Okay, the next question says temperature theta degrees C of cooling body at time t hours is given by, where K is constant, and it says, so this is our equation, and then it says when T is equal to 2, theta is equal to 80, and then find the value of theta when T is equal to 5. Okay, so let's just put T equal to 2, theta equal to 80 into it and see what we get. So that means instead of theta, you'll write 80 is equal to 120 e to the power of 2k, and then we'll bring that 120 across. You'll have 80 divided by 120 is equal to e to the 2k, and then that's the same as just 2/3 in is equal to e to the 2k, which means you could take ln of both sides, ln of 2/3, and taking ln on the right hand side, ln and e cancel each other out. They're what's called inverse functions. So if you take ln on the right hand side, you'll just get 2k, which means k is just equal to a half ln of 2/3. Now we need to find the value of theta. So when t is equal to 5, so first of all let's rewrite our equation. Our equation is then just theta is equal to 120 e to the, and it was t times k, so t times your 1 over 2 ln of 2/3 is t over 2 ln of 2/3. Now you can tidy this up, but I don't think there's any need to. We're just going to put in our value of t. So I would just say when, and they wanted to find theta when t is equal to 5, so when t equals 5, theta is equal to 120 e to the, instead of t, 5 over 2 times ln of 2 over 3. And then if you do that, you will get, and hopefully I've done that correctly, again I've got this one done out here, I got 43.5 degrees C, and that's going to be the 3 sig figs. Okay, next one, question 7 says, a piece of wire is bent into shape as shown. The wire forms the outline of 3 sides of a rectangle surmounted by a semicircle. The rectangle has a width of x and a length of y. The wire is 8 centimeters long. And it says, show that y is equal to 4 minus x over 2 minus pi x over 4. Okay, right. The 8 centimeters is your total perimeter. 8 centimeters is your total perimeter. So 8 is going to be equal to, why is this thing doing this? 8 is going to be equal to, you can see there, you've got x along the bottom, and then you've got 2y, and then you've got your half of a diameter. So it's a half times pi times d, and the d, the diameter, is x, so that's what you have. So let's just tidy that up. That means I'm just going to switch things around. That means 8 minus x minus a half pi x would be equal to 2y. I'm just going to write that in as 2y is equal to 8 minus x minus a half pi x. And then what I could do is divide through by 2. Y then is equal to, everything gets divided by 2, so 4 minus x over 2 minus, and that's pi x over 4, which is what we were looking for. That's an easy 4 marks there. Happy days. The next part says, and I'll scoot back to this, where does it say it? It says, hence find in terms of pi the value of x for which the area of the rectangle is maximum. Okay, so I think this threw a few people here. It was the value of x for which a rectangle is maximum. Now the rectangle is just this. So the rectangle area, we want to find the area of this. The area of this thing is just going to be xy. So that's really what we're looking for here. So let's just write that down. We'll just write down the rectangle equals xy. So that's just x times, let me change this again. That's x times my y, which was 4 minus x over 2 minus pi x over 4. So my area is going to be equal to, that's going to be 4x minus x squared over 2 minus pi x squared over 4. And when you see the words maximum, minimum, point of inflection, turning point, gradient, tangent, normal, any of these words, you should be thinking differentiation. So this is a differentiation question from here on in. So let's just do our dA by dx is equal to 4, and then that's going to be minus 2x over 2, which is just minus x, and then that's going to be minus 2x times pi over 4, which is just going to be x times pi over 2. And then what we want to do is we want to put that equal to 0, because your dy by dx is equal to 0 at a turning point or maximum or minimum. So put that whole thing equal to 0. And I'm going to bring that across, the x's across to the other side. That's what I'll have for my x's is equal to 4. And then I will factorize. So that's going to be 1 plus pi over 2 is equal to 4, which means x is equal to 4 over 1 plus pi over 2. And what you could do to make life a wee bit nicer is multiply top and bottom by 2 to give you 8 over 2 plus pi. Hopefully that's right. Okay. Now what we need to do is test this thing. So we need to look at our d2a by dx squared. So we're going to differentiate this thing here. So if you differentiate that, you're just going to get minus 1 minus pi over 2, which is less than 0. We can't even put our value in. That's less than 0. Therefore, maximum area. And that was, so answer was just x equals whatever we had down here, 8 over 2 plus pi. Hopefully that is what we're looking for. Nice easy 10 marks. Okay, next question is an indices question, which is a fairly tricky one. They have to get tricky really because the new calculators are so good, so they have to get tricky just to sort of be able to test this topic. So here for indices, that's our equation 1, that's our equation 2. Now we're going to change these massively, and I think this is going to lead to a simultaneous equations question, and we will see. Okay, the idea with the indices question is trying to make the bases the same. So our first equation, let's just look at it. What was it? 4 to the power of x equals 32 to the power of y. We can make the bases here 2. So that could be 2 squared to the power of x. And 32 is 2 to the power of 5 to the power of y. So that becomes 2 to the power of 2x equals 2 to the power of 5y. And that means my bases are the same, which means my powers must be the same. So I could say then 2x is equal to 5y. That's what my first equation became. My second equation, I'll do it down here. My second equation was ugly. It was root of 3 to the power of x is equal to 9 to the power of 2y over 27 to the power of y minus 1. So that's what we've got. Okay, got to change this thing. Got to make the bases all 3. So that's 3 to the power of a half, first of all. Power of x. 9 is 3 squared, and that's the power of 2y. And then 27 is 3 cubed, and that's the power of y minus 1. Now sort out the left-hand side, that's easy enough. That's multiply the powers, that's just going to be x over 2. The right-hand side, it's going to be 3 to the power of 4y over 3 to the power of 3y minus 3. And then that's still 3 to the power of x over 2 is equal to, and then this one, you'd be subtracting powers. So what you've got here, when you subtract powers, is 4y minus 3y minus 3. That's going to be 4y minus 3y, minus is a plus. That's going to be y plus 3. And so you're going to have 3 to the power of y plus 3. Again, bases are the same. That means the powers must be the same. So these two things must be the same. So that gives you x over 2 is equal to y plus 3. Multiply across, then x is equal to 2y plus, x is equal to 2y plus 6. X is equal to 2y plus 6, and that's my equation 2. So, okay, I've got x is equal to 2y plus 6, and I've got these two equations here. Where are they? I've got this equation, and I have this equation which we now need to solve. So let me just write those down before I forget them. We've got 2x equals 5y, equation 1, and you've got x is equal to 2y plus 6. You can solve this whatever way you want. What I'm going to do is sub my second equation into equation 1. Now what I mean by that is everywhere I see x, I'm going to replace it with 2y plus 6. And then we're just going to multiply that out. You're going to get 4y plus 12 is equal to 5y. Means 12 is equal to 5y minus y. Oh, 5y minus 4y, which means 12 is equal to y. Is that what I got? I think it was. Yep, it was. That's what I've got. I'll just finish this here then. And then that means, therefore, fire that into equation 1, I suppose. Fire that into equation 1. No, fire that into equation 2. You're going to say then your x is equal to, yeah, well, put it in later, it doesn't really matter, but your xn is going to be equal to 2 times my y, which is 12 plus 6, and then that's x is going to be equal to then 24 plus 6, x is equal to 30. Okay, right, I've messed that a wee bit, so I'm just going to check. So that was my equation 2. I'm just going to check my equation 1 here. So 2 times x, 2 times the 30 equals 5 times my y, 60 equals 60. Happy days, that works. I don't normally do that check, but just lost my train of thought there. So my answer, x is equal to 30, y is equal to 12. Okay, now, oh, 2 blank pages. Oh, 1 blank page it is just. Okay, right. Now this one caused a lot of trouble. I've done this a wee bit differently than, I'll maybe show you 2 methods for this one, if I can remember them. But I've done this slightly differently with one of my colleagues would have done. So my way of thinking about this one, it tells you in this question, it says, below is a sketch of a quadratic curve on a straight line. It doesn't give you the equation of this curve. It doesn't tell you what this curve is equal to, which is a bit weird. But it does tell you the curve crosses the x-axis at 1 and 6, and the curve crosses the y-axis at minus 6. The straight line has equation y equals 4. Find the value of the shaded area. So you need to find this area. That's what they're looking for. That's what this whole question is about. So we've a lot to do here in this question. But first thing I'm going to do is find the equation of the curve. So I'm just going to say, let the curve be, it's a quadratic. So I'm just going to say it ax squared plus bx plus c. Okay? And that is it. Okay. So Now, there's a smarter way of doing this. There is definitely a smarter way of doing this, but this is the way I saw it, and so I'm just going to go with that. Now, you know a few things. You know this point, which would be 0 minus 6. This point, which is 1, 0. And this point, which is 6, 0. So I just sub those in. So I'm going to sub in, first of all, what I just said, 0 minus 6. So that means when x equals 0, y equals minus 6. So that's going to be 0a times 0 squared plus b times 0 squared and plus c. So you get your c equals minus 6. So your equation is y is equal to ax squared plus bx minus 6. Now the other way of doing it is 1, 0. Or sorry, the other point to put in is 1, 0. So that means y equals 0 when x equals 1. So a times 1 squared plus b times 1 squared minus 6, which is the same as 6 is equal to a plus b. Probably guess where I'm going from this. And then the other one was when x equals 6, y equals 0. So that was 6, 0. I'll just put that in. So putting that in, you're going to have then 0 equals a times 6 squared. That's going to be 36a plus b times 6. So 6b and minus 6. So 6 is equal to 36a plus 6b, dot, dot, dot. That's equation 2. I could divide that one by 6 to give you 6a plus b as my equation 2. And then we'll solve those. So we've got those two equations. 6 equals a plus b as my equation 1. 1 equals 6a plus b as my equation 2. And if we subtract those, you're going to get minus 5 is equal to minus 5a. Yep, so is that right? Yes, sorry, you're not going to get minus 5 at all. You're going to get positive 5 if you subtract them. This is why you should write down what you're doing here. So 1 minus 2. So 5 equals minus 5a, which means a equals minus 1. And then sub that in to the other one. So sub that into equation 1. So 6 equals minus 1 plus b. Therefore, my b equals 7. So my equation of my curve, what I found after all this, is my curve is y is equal to minus x plus 7, minus x squared, sorry, plus 7x minus 6. That's what my equation is going to be. Okay, right. That's just to find the equation of the curve, which you need to do. Now I'm going to show you another way of doing finding the equation of the curve. We've still a lot to do in this question, but another way of doing it, which is a much smarter way of doing it really, which was not my idea, but one of my colleagues had this idea, which was a much nicer way of doing it. I said what I was going to do for this one, and he said he had a nicer way of doing it, and it definitely is. Okay, if you look at this, x equals 6, x equals 1, and x equals 6 are roots of the equation, and it's so that means one of the roots is going to be like x. One of the factors is going to be x minus 1, and another one of the factors then is going to be x minus 6. Okay, so that means your equation of your curve is going to be equal to this. And if you did that out, that's not going to quite work for us. Let's see, if we do that out, what we're going to get. It's going to give you x, that's going to give you x squared minus 7x plus 6, but it's not going to quite work because that should have been a minus 6 here. So if we just change one of those, multiply one of those by minus 1, so then that becomes in, we'll just change this one, we'll multiply this one by minus 1, that'll be 1 minus x, and then times x minus 6. And then if we do that out just to check what you're going to get then, check that what's going to work then, that's going to be the same, that's going to be minus x squared, and then you're going to have plus 6x, sorry, you're going to have plus 6, and then plus 1, that's going to be plus 7x, and then you're going to have plus Sorry, you're going to have minus 6. You're going to have minus 6. Apologies, lost my train of thought again. That's going to be minus 6. Let me just check. Is that the same as I had here? X squared plus 7x minus 6. So that's a much quicker way, much quicker way of doing it. So a wee bit of trial and error. Just put a line through that one. And that's it. Okay, another way of thinking about it as well. Maybe a slightly better way of doing it. If you have a look at this again, this one is a root. That's a root. So it's going to be y is equal to, and you could put one of them in, just to show you can do it a slightly different way. I could do the x minus 1 in here, and then this one for the second one then, you know it has to be a negative quadratic because it's an n-shaped graph. So to get the negative x term, instead of doing x minus 6, I'll just get rid of that. I'm going to switch those around, so it's going to be 6 minus x, and you can see if you multiply it out again, you're going to get minus x squared plus 7x minus 6. So there's 3 ways of doing it, and definitely the last 2 ways are the quickest ways of doing it, just to get the curve. Right, all we have done is get the curve, so that's what our curve is. You then want to see where your curve, we need to see what these 2 points are, so where this curve crosses your line, y equals 4. So we're just going to put that curve equal to y equals 4. So just say, now just say put curve equal to 4. So 4 is equal to minus x squared plus 7x minus 6. Let's bring it all to the left-hand side to make the x squared term positive. That's what we're going to have. That will factorize to be x minus 2, x minus 5 equals 0. So that means x equals 2 and x equals 5. That's where your curve crosses your line. So what you had, let's just draw that wee diagram, save me zooming about again. That's what you had. That was your line y equals 4. You now know it crosses here. This is what we want to find. It crosses at 2 and it crosses at 5. So we've got a rectangle. To find this area A, you've got to do the area under the curve minus that rectangle. Okay, let's do the easy bit first. Let's get some marks for the rectangle. The rectangle's area is going to be 4 as the height of it, and the width of it would be 5 minus 2. So that's just going to be 4 times 3. So the rectangle's height is going to be 12. Now the area under the curve is equal to integral from 2 to 5 of minus x squared, what was my curve? Minus x squared plus 7x minus 6 dx. Integrate that, square bracket, that's going to be minus x cubed over 3 plus 7x squared over 2 minus 6x, and that's between 5 and 2. And if I do that, what on earth did I get? I got, that is going to be, that worked out to be, first bracket was 95 over 6. Second bracket worked out to be minus 2 over 3. And then when I did that out, that worked out to be, well, I'm not too sure what that worked out to be. Let's have a look and see. 95 over 6. And then worked out to be 16.5, and that means my area A, remember it was that area under the curve minus a rectangle, which works out to be 4.5 units squared. Okay, so very difficult question. Okay, last question, and again, a couple of ways of doing this one. I'm going to do one way. I'm going to do a completing the square method, I think, for this one. It says find a range of values of p for which this expression is always positive. So let's just look at this thing. We have got 2x squared plus px minus p plus 1, and I am going to complete the square here. So what I'm going to do is just look at this bit here, and I'm going to complete the square for it. So I'm going to take a 2 outside a bracket, which means it leaves me x squared plus p over 2x. I've still got this minus p plus 1 outside here. And I'm going to complete the square in here. So I do that, you half the coefficient of the x, so that's now going to be p over 4. And that's what you've got. So I've got minus p plus 1. I've got to remember to take away that p over 4 squared. It's my additional term. So, right, we want to find the range of values let's go again. We want to find the range of values of p for which the expression is always positive. Now, it will be, this bit here will always be positive no matter what, because you're squaring it. So positive thing squared is positive, negative thing squared is positive, and also 0 squared is just going to be 0. So it's going to be positive when this bit is greater than 0. So we need to say put minus of p plus 1 minus 2 of p over 4 squared greater than 0. So let's just do that out. That's minus p minus 1 minus, and that's going to be p squared over 16 times 2. It's going to be p squared over 8. Put that greater than 0. Bring that across. You'll have 0 is greater than, that's going to be p squared over 8 plus p plus 1. And 0 is greater than p squared plus 8p plus 8. Okay, I hate working with them in that way. I'm just going to bring the thing across. P squared plus 8p plus 8 then is less than this. So here, have a look at what I've done there. I just don't like having that on the right hand side, so that's personal preference here. My arrow is pointing at the p squared plus 8 plus p squared plus 8p plus 8. My arrow is still pointing at that, so I haven't changed anything. I've just switched the sides. So that's what I want. I'm going to have to find this. I'm going to solve this using find the values of p that'll make it equal to 0. So now a quadratic inequality question. P would be equal to minus 8 plus or minus 8 squared minus 4 times 1 times my a times my c all over my 2a, which is just 2. And then when I worked that out, I got two values. I got minus 4 minus 4 minus 2 root 2, or I got p was equal to minus 4 plus 2 root 2. Now it's a quadratic inequality. Look at this, it was a positive quadratic, so it's a U shape. And we now know it crosses here and here. We know the values, that was minus 4 minus 2 root 2, and minus 4 plus 2 root 2. And what do we want? We want less than. Less than means we want below the axes. So below the axes would be these bits between here and here. So my answer is minus 4 is less than 2 root 2 is less than p is less than minus 4 plus 2 root 2. And that's what we're looking for. And that, I think, is us done. Just check, and you go through your answers, and you just check there, but I think that's all finished. Happy days.